Welcome to a brand new episode in Science and Technology Unleashed. My name is Rahil Ramzanli and I will be your host for this series. Maulana Hazrat Imam has said that from the very beginnings of Islam, the search for knowledge has been central to our cultures. Join us as we explore the world of neuroscience and mental health today. These are increasingly important and constantly evolving fields of study with profound consequences on human behavior and well-being. We'll meet industry leaders, scientists, and experts in their fields from the global Jamaat as we try to understand how this new knowledge on neuroscience and mental health is changing our understanding of the universe and how the world may look very different from what we see now. And we're also going to be seeking to inspire, educate, and share that knowledge. Our next guest is Dr. Zul Merali, a neuroscientist and founding director of the Brain and Mind Institute, Aga Khan University. Dr. Merali received a BSc in biochemistry from McGill University and a PhD in pharmacology from the University of Ottawa. Dr. Merali has a tremendous impact in Canada on issues of mental health, especially through his efforts to develop young scientists.
Mental illness is really a biopsychosocial illness. In other words, there are biological, psychological, and social factors that contribute to mental illness. So, mental illness, as you know, affects a lot of people. 1 in 5 of us will have mental illness throughout our life. And it carries one of the largest burdens of illness right now, bar none. More than all cancers put together, more than all heart disease put together. And yet, if you look at the treatments that we have available currently, they're really not very good. About a third of the treatments work really well, but about 2/3 of the people respond a little bit or not at all to the current treatment. So it really begs for us to better understand, first of all, why do mental illnesses occur? What are the underlying causes, and how can we best treat them? We are with mental illnesses where we were with cancer or heart disease maybe 100 years ago. So we have a lot of way to go forward. But what's fascinating is that mental illnesses are all based on the functioning of the brain. And so we need to kind of get into the brain to figure out how does it work and how do malfunctioning circuits in the brain give rise to mental illness. And what's fascinating about this is that the brain, although it's very protected in his skull, engulfed by a very tough membrane, dura mater, so it's insulated organ. But if you look at how the brain functions, it is really probably the most sensitive organ to what happens in the environment. So it can pick up changes in the environment, both outside and within the body, and it responds. Its function is to create the response of the body, be it cognitive response about your thoughts, feelings, emotions, things like that. It could be a flight and fight response, but in essence, it responds to the environment. And we need to understand, why do we respond so differently to the same types of stressors? What is it about the biology, and what is it about the functioning of the brain? So it's a fascinating area. I think things are moving very rapidly these days in this front, and so there's lots to discover. But really the potential of having an impact and finding solutions is going to be absolutely enormous. Life stressors or trauma are the most important factors contributing to mental illness. And during this COVID era, we've seen many forms of stressors impacting on individuals. So first is, for example, economic stress. Then there's this issue of social isolation, which is you cannot see friends as easily, you cannot see your colleagues, you're not going to work. And this kind of leads to loneliness. And loneliness is a major factor in mental illness. And last but not least, you have this situation where you don't have that access to healthcare like you used to before. So those are all factors that actually are due to COVID. But in addition, so these are, as I was saying, environmental stressors and social stressors. But in addition to that, you have the virus itself. It evokes a biological response, a strong biological response, where you have the immune and the inflammatory processes getting activated. And that is a huge internal stressor. So the brain, as I was saying, is perceiving all these stressors. So all of a sudden, you've got a huge amount of biopsychosocial stressors coming in, and then you've got the biological stress evoked by the virus. So it's setting up a situation whereby the mental health is being impacted very widely. The field of neuroscience, understanding how the brain works, is changing enormously, very rapidly these days. And so let me give you some examples of what is the future and how it is changing and where we need to focus. Let me start with some of the drugs. Recently, we've discovered a drug called ketamine. It has a very powerful antidepressant effect. But what's interesting about this is that the typical antidepressant drugs like Prozac and SSRIs, they take weeks or months to kick in. It takes a long time for them to get hold within your body when you have the right doses and the right drug. With ketamine, instead of weeks or months, you're looking at hours or days. So you have a very rapid response. This is important because people get a lot of hope. They understand that their depression can be mitigated. Another area which is really growing very rapidly is that we have a very powerful brain imaging technologies now available for us. So you can actually look inside the brain and see not only the anatomy of the brain in fine detail, all the wiring, but you can actually see the traffic patterns of activity within the brain. So this is a huge breakthrough. It's telling us that the circuits in the brain with people who are showing signs of depression, symptoms of depression, they may have very different underlying causes. And so the more we can learn about the traffic patterns in the brain and the broken circuits in the brain, the more we'll be able to do precision medicine. So we might be able to develop treatments more specific for a specific kind of depression. The other area which is quite exciting is that we're beginning to understand that the brain and the gut, they actually talk to each other. They're not so independent, although they're physically far apart. The other area that is developing rapidly that is very exciting is the area of artificial intelligence. Using artificial intelligence and mobile technology that we all seem to have in our pockets these days, those are powerful tools, and I'll tell you why. Is that, first of all, for example, if you're depressed, and when you talk, your speech, your cadence, your pitch, your tone, your pace is all influenced when you're depressed. And as a matter of fact, using artificial intelligence, we can figure out whether you're depressed or not depressed, just based on your speaking, your speech. And as a matter of fact, what's interesting is that this technology is starting to tell us when somebody is on the way to getting depressed. And last but not least, I think that the technology is also changing the world of how we deliver care. Right now, you know, when you have to go to a doctor's office or to go to a psychologist or go to see a psychiatrist, many people in the developing countries don't have that luxury, and they don't have access, and they don't have the money. And we need to figure out, I mean, a lot of people are suffering. All the statistics I gave you, those are numbers. But behind those numbers are people with dried tears. I mean, people suffer a lot with mental illness. And we need to figure out, how do we actually give them help that they need? And if we give them help early on, before they develop full-fledged mental illness, then they'll benefit from this a lot. Technology is going to be a pathway to that. So I see a lot of potential in that area to kind of mobile technology and even telepsychiatry, where we can talk to the doctors remotely, or the psychologists remotely, to get the help that you need. So I think those are some of the ideas for the future. So the advice that I would give to the youth, essentially, is that the youth these days are experiencing a lot of stress. It's I see that. I see that in my own children. I see that in the kids. I call them the kids I teach at the university. Um, People feel a lot of stress from many different areas, and I think that for the young people, it is important to kind of keep in mind that you need to be vigilant about your mental health, and there are many mitigating strategies. For example, in terms of being active and having exercise that has a very positive impact on mental health, having a very good sleep regimen, which is important because sleep is often disrupted and has a very negative consequences down the road, and so on and so forth. But for youth to get engaged, as I said, into the realm of mental health from two aspects. One is look after your own mental health. I think it's important. It's important to have friends and family and mitigation strategies in place, be aware. And when help is needed, you need to kind of put your hand up and say, I need help. There's nothing wrong. Nothing wrong with mental illness. As I said, it's going to be impacting 1 in 5. So if you look around you and you've got 5 friends, well, one of them is going to have mental illness, and it may be you. So let's not be judgmental, and let's be supportive and be open. And this is a tough thing to do because mental illness carries a big stigma.
It was incredible to hear the progress that has been made in mental health and the steps we can take to improve our life. Our next guest, Dr. Nazim Virji Babul, PhD in Neuroscience, is an associate professor in the Department of Physical Therapy, Faculty of Medicine, and senior advisor to the Provost on Women and Gender Diverse Faculty at the University of British Columbia, Vancouver, Canada. Her research addresses fundamental aspects of brain behavior relationships in typical and atypical development.
So my research, what I do is I study babies. I want to understand how babies learn, what they think about, how do they actually understand the actions, the emotions, the intents of other people. How can we figure this out? Young babies can't talk, they can't tell us what they're thinking. So how do we actually understand what babies can think about? Almost 50 years ago, we used to think that babies were born as blank slates, that they were just really just blobs that came into this world, that they slept a lot, they cried a lot, they pooped a lot, and if the parents were lucky, they smiled at them every now and then. And we thought that, it was coming through and being part of life that actually helped them to learn things. We now know that that's completely untrue. This is part of the debate about nature versus nurture. We now know that babies are actually, they're like little scientists in training. They can perceive their environments, they understand patterns, they are born being able to understand any language that exists in the world. And they actually can detect patterns in the environment. They can actually understand simple math. When they're given tasks, when we ask babies to do things or to look at things where things aren't quite the way they should be, they frown, they give us some ideas that they actually understand patterns in the world around them. What I'm interested in understanding is how do babies learn about emotions? How do they learn about actions? How do they learn about empathy? And how can we tell that when a baby is just a few months old? So what I do is I use some very specialized equipment called EEG. And this EEG comes as a form of a cap. I put this cap on there, which has electrodes on it. And what the electrodes do is that they actually can record signals from the brain that's underneath the skull. And by analyzing the patterns, these patterns that are in their brain, I actually get a glimpse into what's happening inside their brain. And I can understand what it is that they're actually thinking about and how they're learning as time goes on. So one of the things that I'm really interested in is about the perception of emotions, the perception of intentions. And there's one discovery that was made quite by accident about 10 or 20 years ago by an Italian neuroscientist. And he was studying how monkeys actually learn to control their movements. So he had monkeys in a chair, similar to how I'm sitting, but their hands were strapped down. and he opened up their skull, and he had some electrodes, and he put them on the brain to actually record the signals of the brain while the monkey was making certain kind of movements. And at one point, just by coincidence, one of his graduate students walked into the lab, and the graduate student had a banana, and he started peeling the banana and started eating it. And amazingly, the monkey who was sitting there, the neurons, the cells in his brain that actually are related to movement, started firing. They started firing while he was watching this person eat a banana. And he wasn't doing anything. He was strapped down by the chair. And so by accident, we discovered that there are specialized neurons in our brain that actually respond to other people's actions, other people's emotions, and other people's intentions. And we are actually, it seems like we are born with these neurons, and they get refined over experience. So there's a lot of things that are happening in neuroscience. There's just an explosion right now. It's one of the areas where we're starting to see input from cognitive psychologists, from people who do physics, engineering. There's a big push towards cognitive neuroscience. And all of this has helped us to get neuroimaging tools that are giving us finer and finer details and information about what exactly is going on in the brain. There's two things that I specifically want to highlight. One is that we used to think that all of the development in the brain kind of was completed by the age of, say, 5 or 6. This is why we have a big push on early childhood development, on the 0 to 5 sort of age range. But we now know that the human brain actually is not completed in its development until the late 20s and even early 30s. And it may surprise you that development goes on so far. From puberty to about the age of late 20s is the second most dynamic period of brain development. There's an explosion in social emotional development, and that's something we're just learning about, that this second explosion of development is actually really spectacular. And it's also a time where parents really need to be involved in their child's development, because this is a time when the kids are actually like sponges. They are absorbing so much new information. And the fact that they are surrounded right now by social media, by their peers, they're getting information from lots of different sources, that their brain is trying to make sense of that. And they're also at a stage where the information about their social development is much more heightened. They're influenced a lot by risk-taking, for example. And so there is almost a disconnect between the brain's development for social emotional kinds of development compared to their cognitive development. So their cognitive development is actually a little bit slower in pace compared to these other regions. These are the areas that actually help them to get to their next stage of development. And what we're learning about this from some of the neuroimaging is that we can now actually see these changes that are happening both in terms of the structure and function. We can see the changes that are happening and how they're increasing, how certain tracks are increasing in their volume, for instance, how the networks are becoming much more complex and integrated. So no matter what the task is, the entire brain is communicating. Different parts of the brain are communicating with each other. So those are the two most important things that are happening right now in the field. So I think that, to the parents, what I would say is, don't impose your ideas on what you think your children should do. Just give them lots of different opportunities to experience different things, whether it's in the arts, whether it's in music, whether it's in science. Just seek out all these opportunities and give them those experiences. For students, they often feel very shy about approaching professors when they're at the university. And I get a lot of students at the first day of class. This year, of course, it's very different, who are lining up outside my door asking for any kind of internships or volunteer work, just to understand how does the lab work? What sort of experiments are you doing? Can I get involved in that? I think it's really important that people who want to go into the sciences or into any kind of academics, that they need to get experience of what that actually feels like. What does it look like? What does it mean to do some work in a lab of somebody, one of the professors? So I would really suggest that you try and get that students or whoever is interested in this to go and approach the professors. Most of them would love to talk about their work. In fact, you have a hard time getting them to stop talking about their work. And they are usually very willing to have undergraduate students come and observe what's going on, or if they think you're actually good enough, then they will invite you to come in their lab. And by going to different labs, students will get an idea of what's actually out there. They'll get hands-on experience and get to really see what are the new fields out there. What sort of new and exciting work is being done that they would be interested in getting involved in. It's very different from just reading papers and thinking theoretically and talking to people. Once I find when students come into my lab and actually have to put on an EEG cap on an infant and then look at the brain signals afterwards, seeing that in real time, trying to analyze those signals, they start to understand the process of what research is all about, what science is all about. It's not about the scientific method that they learn about in high school. It's much more dynamic, it's very active, and it involves a lot of creativity. And I think a lot of students don't realize that when they're thinking about careers in science. When you have fulfilled your goals and you've become a leader in your field, remember that you also have to give back and be a mentor or a sponsor to somebody else to make sure that the next generation is going up. Do not let anybody hold you back. As Ruth Bader Ginsburg has said, speak your mind, even if your voice quivers. And I want to tell this to all the girls and all the women who are listening to this.
1,000 years ago, the mathematician and philosopher Yaqub al-Kindi expressed a sentiment similar to what we heard last week and aptly captured the spirit of his time. We ought not to be ashamed of appreciating the truth or acquiring it wherever it comes from, even if it comes from races distant and nations different from us. For the seeker of truth, nothing takes precedence over the truth, and there is no disparagement of the truth, nor belittling of him who speaks or conveys it. No one is diminished by the truth. Rather, truth ennobles all. Our next segment will explore the role of science in Islam.
René Descartes famously once said, "I think, therefore I am." This dualism brings into sharp focus how the immaterial mind interacts with the material body. How can we understand and define the mind? Is there a relationship between the mind and the brain? Consider how the mind works. How are our thoughts formed, our feelings felt, and our memories made? These are but some questions that continue to pique the curiosity of scientists, artists, philosophers, and the like. Early Arabs and Muslim scholars defined the term mind more broadly. They used the term nafs, self or soul, to indicate individual personality, and the term fitra, nature, as an indication for human nature. The word nafs then includes the qalb, heart, the ruh, spirit, the aql, intellect, and irada, or will. While scholars discussed and wrote extensively on each aspect of the nafs, the intellect and the proper use of intellect was often at the center of many debates. In the Quranic view, the whole of creation is an ayah, a sign of God. As Muslims, we are called upon to use our intellect to reflect upon the reality of creation and to give thought to what we perceive and experience with our senses and our minds. Al-Mu'ayyid draws attention to the need for the seeker to go beyond the apparent in his search. But in order to do so, the intellect needs to be illuminated by a light from outside. For some, this light refers to the divine light, the divine intellect. In his speech at the inauguration ceremony of the Aga Khan University, Pakistan, Maulana Hazri Imam explains that the divine intellect, Aql Kul, both transcends and informs the human intellect. It is this intellect which enables man to strive towards two aims dictated by the faith: that he should reflect upon the environment Allah has given, and that he should know himself. It is the light of the intellect which distinguishes the complete human being from the human animal, and developing that intellect requires free inquiry. The man of faith who fails to pursue intellectual search is likely to have only a limited comprehension of Allah's creation. Indeed, it is man's intellect that enables him to expand his vision of that creation.
Our next segment covers the weekly digest covering emerging technology, trends, and extraordinary articles handpicked to broaden your horizons and challenge our thinking. In this segment, we will be introducing the functionality of artificial intelligence, or AI.
A company in France is growing bugs for fish feed, fertilizer, and pet food. Farmed fish are fed smaller fish and crops that are grown on land, which can be costly. The company's facilities grow beetle larvae in vertical farms 130 feet high. It aims to produce 20,000 tons of insect protein each year and is already working with the biggest fish feed company in the world. It plans to start production in 2022. Flippy the robot who rose to fame flipping burgers is now able to make lots more dishes in the kitchen. It looks as if this will continue to herald a transformation of the restaurant industry. To date, Flippy can cook 19 different items, anything from corn dogs to chicken tenders, but that number is sure to expand now that the robot is trainable, thanks to an upgraded machine learning system. The company first gathers around 1,000 shots of the dish in various states of doneness. The company then feeds those initial photographs into a computer to create 1 million pictures of chicken nuggets and then uses that to train the algorithm to identify accuracy. Scientists have developed a new gene editing tool that, for the first time, can target the specific cells or organs that doctors want edited, including specific areas of the brain. While testing on lab mice, the Tufts University biomedical engineers developed a gene editing tool that could specifically target organs like the liver, alter cells in the immune system, and cross the blood-brain barrier that protects the brain in order to edit specific brain cells as well. And because the tool is directly injected into the bloodstream, it could lead to a straightforward way to perform genetic treatments, should it end up working on people as well. More than 1,000 AI scanners are monitoring how close pedestrians get to each other in London, Manchester and other British cities to supply the government with data on social distancing. The sensors were initially intended to track the flow of traffic, cyclists and walkers to work out how roads were being used, but after lockdown, in March, they were fitted with a new feature. Manufacturers Vivacity said the data is used to inform policy decisions, and in response to privacy concerns said that none of the footage is saved, streamed or used for enforcement purposes. Plenty is a San Francisco-based startup that wants to build at least 500 vertical farms around the planet in densely populated cities. The first Plenty farm went into production in 2018 and its second site is in Compton. Vertical farms can produce food efficiently all year round while taking up significantly less space than a traditional farm.
Finally, let's hear what Maulana Hazri Imam said about neuroscience at the Madrasa Program 25th anniversary.
It is striking that modern neurosciences have demonstrated that long before the age of 6, children are aware of the different cultural backgrounds amongst each other in their classes. It is thus before that age that pluralism can be instilled as a life value.
See you next week.